This is lesson 25 on angles and quadrants. So we're starting our second trigonometry unit. We just finished reviewing grade 10 trigonometry, and now we're going to start grade 11 trigonometry. So our learning goal for today is learning to find the 6 trigonometric ratios of an angle that's said to be in standard position. So we're going to look at trigonometry in a very new way in this unit. But we're going to start off with some things that are familiar that we just reviewed from grade 10 trig. So for a right triangle, there are 3 primary trigonometric ratios: sine, cosine, and tangent. We learned them last year. But there's also 3 reciprocal trig ratios. So reciprocal means upside down or flipped, okay? And they're called cosecant, secant, and cotangent. So let's look right now at our angle. So this is our angle theta. According to the angle theta, this is the opposite side. The side across from the right angle is the hypotenuse, and the side that helps form the angle with the hypotenuse is the adjacent. So we're used to these primary trig ratios right here, and that is that the sine of theta is equal to the length of the opposite side over the length of the hypotenuse. The cosine of angle theta is the length of the adjacent over the length of the hypotenuse, and the tangent of angle theta is the length of the opposite over the length of the adjacent. So the reciprocal trig functions correspond. So sine and cosecant are reciprocals of each other. So CSC stands for the cosecant of angle theta, and it's the reciprocal, so instead of opposite of our hypotenuse, it's hypotenuse over opposite. Secant is the reciprocal of cosine, so instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And cotangent is the reciprocal of the tangent, so it's adjacent over opposite. So you've got to hopefully you have these 3 memorized using SOHCAHTOA, but then you just have to remember that cosecant goes with sine. So when I was in high school, I used to remember S goes with C, and then C goes with S. So sine, theta, and cosecant are reciprocals, cosine and secant are reciprocals, and tan and cotangent are reciprocals. So if you know the primary and you know the names of the reciprocal and how they correspond, you'll know the reciprocal functions as well. So our first question is pretty straightforward. We're just going to use our new formulas. So state the 6 trigonometric ratios of angle theta. So here's angle theta. We know all 3 side lengths. We're going to label them according to angle theta. So here's our opposite side, the hypotenuse, and the adjacent. So the sine of angle theta is opposite of our hypotenuse, so it's going to be 5 over 13. And then immediately I would go, okay, well then I know then that the cosecant of angle theta is the reciprocal, so hypotenuse over opposite, 13 over 5. Cosine of angle theta is adjacent over hypotenuse, so 12 over 13, which means the secant of angle theta is 13 over 12, the reciprocal. And the tangent of angle theta is opposite over adjacent, so 5 over 12, which means the cotangent of angle theta is going to be 12 over 5. Okay? Make sure you have theta in there. Neither sine, cos, tan, they can't stand alone. It has to be the sine of something, and usually that's an angle, okay, or it is an angle. It could be a known angle like sine of 45 degrees or an unknown angle like theta. All right, so there's our first question, pretty straightforward. Just we've learned 3 new trigonometric ratios: cosecant, secant, and cotangent. So this year in grade 11 trig, we're going to look at trigonometry from a different perspective. We're going to define angle theta to be in standard position when it's an angle that's measured from the positive x-axis to the terminal arm of the angle. So for instance, in the diagram that I've started to draw here, we've got our x and y axis. The x-axis is always called the initial arm of the angle. And wherever we plot a point, pxy, we're going to join the origin and then draw a line through, or I guess a directed line segment through that point. And that line segment that we draw here, our directed line, is going to be our terminal arm. And the angle that goes from the x-axis to the terminal arm is going to be considered to be angle theta. So if we know this point, pxy, then we can create a right angle triangle by drawing in from the point down to the x-axis so that it meets at 90 degrees. If that's the case, then this distance here from 0, 0 to here is going to be x, because we would go over x and up y to get to this point. And this distance here would be called y. So over x, up y to get to that point. And when we're in grade 11 trig, we call this distance here r. For radius, I guess, kind of, because you can think of this points moving around. And x, y, and r are sides of a right angle triangle, so they follow the Pythagorean theorem in that the hypotenuse, which we're calling r, squared is going to be x squared plus y squared. So we know that that's related by the Pythagorean theorem. So if we just looked at this diagram right now, we would know that sine theta is, so according to theta, the opposite side is the y value, the adjacent side is the x value, and the hypotenuse is r, is considered to be r. So sine theta, rather than doing writing out opposite over hypotenuse, we can now use this notation y over r. And y has meaning. It's the y value of the point of the terminal arm as plotted on an xy axis. And then, so we would immediately then know that the cosecant of angle theta was r over y, because they're reciprocal functions. The cosine of angle theta is adjacent, or x, over r. And that x value, again, has meaning. It's how we would plot a point on the xy plane. So then right away we would know the secant was r over x. And then the tangent of theta is the opposite over the adjacent, or the y value of the point over the x value of the point, making the cotangent of angle theta the x value over the y value. So grade 10, if I move back up here, this is what we focused on, SOHCAHTOA. And we didn't even talk about the reciprocal functions, and we always had them in terms of opposite, adjacent, and the hypotenuse. So what we want to move towards in grade 11 is thinking of sine as being the y value over the r value, cos being the x value over the r value, and tan being the y value over the x value. And then plotting a point on the xy plane, and then theta always being the angle between the x-axis and the terminal arm. We'll talk about that a bit more in a second. So we're going to start off in the first quadrant, and in this case here, this is quadrant 1, where both x and y are positive. This is quadrant 2. We'll talk a bit more about that as we progress through the lesson. Quadrant 3, where x and y are both negative, and quadrant 4, where x is positive and y is negative. Okay, so we're going to start off with a question, a fairly straightforward question that focuses on plotting a point in quadrant 1. All right, so the point 3, 4 is on the terminal arm of angle theta. Grabbing a ruler here, which you guys should have. Sketch angle theta in standard position and determine the 6 trigonometric ratios. Determine angle theta to the nearest degree. So I'm going to start off by doing a sketch of just the XY plane for now. And these sketches in this unit are always going to be what we call representative sketches. We're not going to get a protractor and a ruler and measure out lengths. Okay, we're just going to draw it in. We know this is our x-axis and this is our y-axis. So if we were to plot the point 3,4, we're just going to roughly estimate. I'm not even going to put little tick marks here, but 3,4, we know it's going to be in the first quadrant. And then we want to join, I guess it's called a ray, so from 0, 0 through that point and beyond. And then we want to, from our point, draw a line down to the x-axis to make a right angle. You always draw down to the x-axis, never towards the y-axis. So that point there is the point 3,4. But why that's so important is because we now know that this side is 3 long and this side here is 4 high. Okay? And it says the point 3,4 is on the terminal arm, so this is the terminal arm right here. Remember, the initial arm is always the x-axis of angle theta. So we haven't even drawn in angle theta yet, and that's the most important part of the sketch to get your marks here. So angle theta is a directed angle, so we want to show that it's from the x-axis to the terminal arm. So we're going to use an arrow showing that angle theta starts at the x-axis and goes towards the terminal arm. And I'm just going to label that theta. So that's angle theta. And to have sketched angle theta, and it'll probably be out of something like 3 marks, you have to label the x and y axis, angle theta with your directed arrow here, label it, your 90-degree angle, and the 3 sides of the triangle it's formed. So far we have 2 of the sides, but we can use the the Pythagorean relationship to get the 3rd side, r, which goes from here to here. So r squared, it's a hypotenuse because it's across from the right angle, is going to be x squared plus y squared. So square root. Now r is always a positive value, which is really important. It's a distance, okay? So when we go into other quadrants, x and y can change signs, but r is always positive. So we'll come back to that, but that's really important. Okay, so now that we've labeled all 3 sides, the angle, the right angle, we've got like 3 out of 3 on our sketch. Sketch angle theta in standard position. So standard position means we're measuring from the positive x-axis counterclockwise towards the terminal arm. And we want to determine the 6 trig ratios. So you are going to be memorizing them. So back in grade 10 again, it was so, if I can fit up here, I'll move it down a little bit here. So helped us remember opposite over hypotenuse. Okay, so according to angle theta, opposite, but that's our y value, okay? We're trying to get away from opposite and move towards y value, okay? And hypotenuse, so again, we're trying to move away from hypotenuse and towards r, okay? And then this side is x. Last year we would have called it the adjacent side, okay? So again, we're moving towards thinking of the sign as not opposite over hypotenuse, but y over r, remembering that, the y value over the r value. So that's 4 over 5. And then, so then immediately then we would know the cosecant of angle theta is 5 over 4, or r over y. Then the cosine of angle theta is x over r, last year, adjacent over hypotenuse is here x over r, so 3 over 5, which means the secant of angle theta is 5 over 3. And then the tangent of angle theta is opposite over adjacent, or the y over the x is what we want to think of it as, y over x. So meaning the cotangent of angle theta is x over y, or 3 over 4. So now we've determined the 6 trig ratios. So we've done that, we've done that. Now the only thing we haven't done is determined angle theta to the nearest degree. So we can go back to grade 10 trig in order to figure that out. So we're looking at a right triangle where we know all 3 sides and we're trying to find that angle. So we can choose 2 of the sides to use. Often people chose tan if they had a choice. So right away we know tan theta is 4 over 3. And we know that to get angle theta by itself, we have to undo tan. So we want to take the tan inverse of both sides, which would mean that theta would be exactly equal to the tan inverse of 4 over 3. And then you want to make sure you can put that in your calculator effectively. So you want your calculator in degrees. And either you're going to press second tan 4 over 3 equals, or 4 over 3 second tan equals. And you should get 53.1, so approximately 53 degrees to the nearest degree. So we did that. So now we've answered all of the questions. Okay, so that's kind of like what the new trigonometry is going to be a little bit based around. We did a question in the first quadrant, which is the easiest one to do because we don't have any negative signs to worry about. And our angle theta ended up being an acute angle, so between 0 and 90. All right, so moving on. The Cartesian plane is divided into 4 quadrants. The terminal arm of an angle could lie in any of those quadrants. Okay, so we already talked about if it's in quadrant 1, the angle is going to be between 0 and 90. But what if your angle was in quadrant 2? Well, the angle theta goes from the positive x-axis around to the terminal arm. So there would be my angle theta, and we can see it would be between 90 and 180. Okay, so or an obtuse angle. Down in quadrant 3, for instance, you could draw it anywhere in quadrant 3. So now we'd be looking at an angle coming all the way from the positive x-axis around to the terminal arm here. Maybe we could call that angle unknown angle alpha. But you can see, or no, alpha's not good. We'll call it beta. That it's going to be between 180 and 270. And if we wanted to draw it in the 4th quadrant, the angle we'd be talking about would be between 270 and 360 degrees. Okay, so we're going to try a question now and see what difference that makes in how we do the question. So the point P negative 8, 15 is on the terminal arm of angle theta. Sketch angle theta and state its 6 trig ratios. Determine angle theta to the nearest degree. So we're going to start off again with a diagram. A labeled diagram of angle theta. Again, these are going to be worth lots of marks, so it's good to be able to do them well. And we always label our x-axis and our y-axis. And then we'd have to say what quadrant is the point negative 8, 15 going to be in. So from 0, 0, negative 8, positive 15 is going to be in the 2nd quadrant. So we can just pick a point. It's a little, say here, negative 8, 15, for instance. And then we can, remember we're not using a protractor or a ruler for measurement purposes. We just want a representative sketch. So that means that this is the angle we're talking about here. The angle from the positive x-axis to the terminal arm. And so we're going to call that angle theta. Okay? But when we make our triangle, we're again going to go from our point right down to the x-axis to make a right triangle. So you can see that angle theta isn't even inside the triangle that we're drawing. But we've made a right angle triangle, and we know that if this point here is -8 and +15, then this is going to be -8, the x distance, and this is going to be +15. Okay, so to get from 0, 0 to the point -8, 15, we go -8 up 15, and we get to our point. So we've almost labeled all the parts we need of angle theta, but we haven't figured out r yet. So we're going to use the Pythagorean relationship. So r squared equals, and I'm putting the -8 in brackets because I'm squaring x, which is a negative number, but you know when you square a number you always get a positive. So we've got r squared equals 64 plus 225, which is 289, and then we're going to square root 289, and that gives us 17. And remember, r is always positive. It doesn't matter which quadrant we're in, r is always positive. Maybe we can come back up here and write that down. R is always positive. And we can see from the 4 quadrants that in this one, x and y are positive or greater than 0. Here, x is negative, y is positive. Here, x and y are both negative, less than 0. Here, x is positive, y is negative. But r is always positive. Doesn't matter which quadrant we're in, r is always going to be greater than 0 or positive. Okay, so if we're coming back to this question here, we've now got 3 out of 3 for our diagram. Okay, so we've labeled angle theta appropriately. Now we want to figure out the 6 trig ratios. So I'm going to start with sine of angle theta, which, so again, here's x, here's y, and here's r. So because theta is not even in the triangle, thinking of it as opposite over hypotenuse isn't as great as thinking of it as the y value over the r value. And then that means the cosecant of angle theta is going to be 17 over 15, reciprocal. The cosine of angle theta is the x value over the r value, which means the secant of angle theta is going to be 17 over -8, but you can move that negative. It can be with the top number, with the bottom number out front. We learned that in grade 9. So I usually always leave it with the top number. And then the tangent, of angle theta is the y value over the x value. So 15 over -8, so I would write that as -15 over 8. And the cotangent of angle theta, -8 over 15. So there's our 6 trig ratios. Now they want us to determine angle theta to the nearest degree. So we know that here's 0 degrees, 90 degrees, angle would be this angle here, and this would be 180. So we should know that our angle is going to be between 90 and 180. So how do we find it? Well, we want to go back to a grade 10 triangle. So we want to pretend that we want to actually find this angle in here. And once we find that angle in here, we should know for sure that angle theta, this is a true statement, so I'm going to write it over here for a second. So we know that theta is 100%, 180 degrees minus whatever alpha is. So this whole distance, which is 180, subtract off alpha will give us theta. Okay, so that means I need to find alpha. So to find alpha, I could go back in time to grade 10 and I can have this triangle. So I'm drawing this triangle over here where this is alpha, this is 90 degrees, this is 17. All my sides are positive because we've got an acute angle here that we care about finding. So we've got like an all positive triangle. So I want to find this angle that fits right in there. So I can use sine, cos, or tan, whatever I want. I'm going to choose tan just because we often choose tan. So I'm doing the tan of alpha is equal to 15 over 8. So alpha is going to be the tan inverse of 15 over 8, or approximately 62 degrees. So 61.9, so I'm going to say 62 degrees. But we said that theta was for sure 180 minus alpha. So 180 minus 62, and it's rounded because alpha was rounded. So it's approximately 118 degrees. And then look and see if that makes sense. So it's bigger than 90, smaller than 180, a little closer to the 90. So 118 degrees makes perfect sense. Okay, so let's recap what we did here. We sketched the angle in standard position, labeled all three sides, labeled angle theta, very, very important. We found r by using the Pythagorean relationship, stated the ratios y over r, x over r, and y over x, and then their reciprocal ratios. Then we figured out the relationship that theta was going to be 180 minus whatever alpha turned out to be. And then we created a triangle, an acute triangle with alpha that had all positive sides, like a grade 10 triangle. Figured out what angle alpha was using the tangent ratio, although we could have used sine or cos because we knew all three sides. Figured it out to be 62 degrees, and then subtracted 180 minus the 62 to get our 118 degrees. Okay. Next question is here. No, sorry guys, I'm looking for it. There it is. Okay, so the point Q, negative 24, negative 7 is on the terminal arm of angle theta. Sketch angle theta in standard position and state each of the following. All right, so the first thing we're going to do is make a sketch. So I've got my x-axis and my y-axis. If I was going to plot the point negative 24, negative 7, it would probably be about here in the third quadrant. We're just approximating. So here's angle theta, starting at the positive x-axis and going to the terminal arm. So there's theta. Then we're always draw our right triangle to the x-axis. And then we want to label the three sides of the right triangle that we made. So to get to this point, we knew that the x was negative 24 and the y value is negative 7. And we still need to figure out the r. So we're going to use the Pythagorean relationship. So negative 24 squared plus negative 7 squared. So that's 576 plus 49. $625. Square root both sides. And we get that the radius is 25. Remember, always positive, doesn't matter which quadrant we're in. So now we've got a perfect sketch, 3 out of 3 on our sketch. They want the sine of theta, so that's the y value over the r value. So the y is negative 7. The r is 25. The cotangent, so that's the x value over the y value, so it's negative 24 over negative 7, but that's not simplified because a negative divided by a negative is a positive. So you must simplify that, you can't leave it unsimplified. Sine squared theta plus cos squared theta. So we haven't seen that notation, let's call it, before. What that means is sine theta squared. It's just a shorter way of writing it without the brackets, plus cos theta all squared. So we figured out the sine theta up here it was negative 7 over 25, so I can replace sine theta with negative 7 over 25, but I'm squaring it. And then cos theta, that's the x value over the r value, so negative 24 over 25 squared. And then when you square a fraction, remembering back to grade 10 and grade 9, you square the top and the bottom. So 24 squared, we figured that at 576. And square the bottom. So you end up, when you add those two together, getting 625 over 625, which equals 1. So the sine squared theta plus cos squared theta equals 1. And now we want angle theta. So we're going to add in angle alpha here. And we're going to make the statement that theta is 100% for sure. We can see it's 180 plus that extra distance, so it's 180 degrees plus alpha. But then we have to find alpha. So I'm going to redraw this triangle here. So here's alpha. Here's my right angle. We're going to make an all positive grade 10 triangle. And then we want to find angle alpha, so we can use tan if we wish. So tan of alpha is 7 over 24. Then I need alpha was going to be this tan inverse of 7 over 24, which means it's going to be approximately, make sure you're in degrees, 16 degrees. So then theta is going to be approximately 180 plus 16, so 196 degrees. All right, next question. Angle theta is in the fourth quadrant, and the secant of angle theta is 13 over 5. Sketch angle theta in standard position. Okay, so they did not give us a point this time. Instead, they gave us one of the 6 trig ratios, which we have to understand is a way of giving us information about x, y, or r, 2 out of the 3. So we have to know that secant is r over x. Okay, another way of thinking about it is secant and cos are reciprocals. Cos would be 5 over 13, and cos is the x value over the r value. Either way, we're being told that x is 5 and r is 13. So I can draw my terminal arm in the fourth quadrant. Just a representative diagram. My angle is going to be all the way from the positive x-axis around to the terminal arm. This is theta. Then we're always going to create our right triangle with the x-axis. And so we know that the x side is 5 and the r side is 13, but we don't know the y side. So we will use our Pythagorean relationship to figure that out. So we know r is 13 squared equals 5 squared plus y squared. So we get that y squared equals 144. But x and y, they can either be positive or negative. So y can either be positive or negative 12, and it will depend on the diagram which quadrant they say we're in. So if we're in the fourth quadrant, it makes sense that we would be plotting the point 5, negative 12, not 5, positive 12, which would be in the first quadrant. Okay, so we now can say that the y value is negative 12. That's the one that makes sense. So part A, sketch angle theta in standard position. We did that. Labeled all 3 sides, labeled theta. Determine sine theta. So B determines sine theta. Sine theta is the y value over the r value, so that's negative 12 over 13. and cotan theta. So cotan theta is the x value over the y value, so 5 over negative 12, but we'll write it as negative 5 over 12. And then C says determine angle theta to the nearest degree. So in order to do that, we need to figure out angle alpha in there. And hopefully you can see that angle theta is going to be the whole way around, which is 360 degrees, subtract angle alpha, this piece in here, and then we'll know angle theta. So in order to figure that out, we have to figure out angle alpha. So I'm going to draw a grade 10 triangle again, where this is alpha and all my sides are positive. And I can say that the tangent of alpha is 12 over 5. So alpha is going to be the tan inverse of 12 over 5, which is going to be approximately 67 degrees if you round to the nearest degree. So that means theta is going to be approximately 360 minus 67, or 293 degrees. So if we just go back here for a second to the page before, in quadrant 1, we can just find theta straightforward. In quadrant 2, theta is always going to be 180 minus alpha. In quadrant 3, theta is always going to be 180 plus alpha. And in quadrant 4, theta is always going to be 360 minus alpha. So those are our relationships. Theta, you just get it directly in quadrant 1. Oh, I'm on the wrong part here, sorry. Go through that again. So in quadrant 1, you just get theta directly. In quadrant 2, you get theta by finding little alpha, but it's related, it's going to be 180 minus alpha. In quadrant 3, theta is always going to be 180 plus alpha. And in quadrant 4, theta is always going to be 360 minus alpha. You can add those onto your diagram there to help you. We're going to try one more of these questions where we're not given a point, but we're given one of the 6 trig ratios. Okay, angle theta is in the 3rd quadrant. So we've already got, we know it's in the 3rd quadrant. And they're telling us the cosecant, which also tells us the sine of theta. And it says it's negative, so sine is going to be 4 over root 65. But we know that sine is y over r, and r is always positive. So that means this negative must go with the 4. The y value must be negative, since r is always positive. So we're just going to draw a representative angle in the 3rd quadrant. Pick a point along it. Here's angle theta. Here's our right triangle drawn towards the x-axis. And we're drawing it so that we know that the y value is negative 4. So over x down y, or left x down y. And r is the positive square root of 65. R is always positive. And just in case, if you're doing the practice sheet and you get x, y, or r to be a square root that isn't a perfect square, you want to leave it as a square root, not as a decimal approximation. Okay, you want to be exact. All right, so now we need to find x, so we're going to use our Pythagorean relationship here. So r is the square root of 65, but we're squaring that. X is what we're trying to find. So square root of 65 squared is 65. Subtract 16 on both sides. get 49. So then it's up to us to figure out whether it makes sense for x to be positive 7 or negative 7 according to the diagram. But negative 7, because from 0, 0 we would go left 7 or 7 in the negative direction on the x-axis and down 4. So now we've sketched and labeled angle theta, check. Part B, determine the other 5 trig ratios. So we already wrote down sine, but I'll write it down again. So sine is negative 4 over root 65. Cos theta is the x value over the r value, so negative 7 over root 65, which means that secant of theta is going to be the reciprocal. I'm just going to leave the negative on top. The tangent of angle theta is the y value divided by the x value, but that reduces to positive 4/7, which means the cotangent of angle theta is going to be 7/4. So we've done A and B. Determine, C says determine 2 times the sine of theta times the cosine of theta. All right, so we can replace sine of theta with negative 4 over the square root of 65. And we can replace cosine of theta with negative 7 over square root of 65. And then if we change this to 2 over 1, it's like multiplying 3 fractions together. So you multiply the tops together, and you're going to get positive 56. And if you multiply the bottoms together, you get root 65 times root 65, which is 65 times 1. And then you can see if you can reduce that, but you can't. So 2 times sine theta times cos theta is 56 over 65. So let's look at our success criteria. The first one is we can sketch and fully label an angle in standard position. Okay, so we've done that pretty much on every question. Hopefully you'll be able to practice that and make sure that you can do it. You can determine the 6 trig ratios of an angle in standard position. What I really want you to do is be able to say and know that sine theta is the y value over the r value. Cos theta is the x value over the r value. And tan theta is the y value over the x value. So the sooner you start to think of sine, cos, and tan in terms of x, y, and r rather than opposite, adjacent, and hypotenuse, the better this unit and the next year in grade 12 functions is going to go for you. Our third success criteria is we can determine the measure of an angle in standard position by finding the related acute angle alpha and relating it to the diagram. So that's where we make our all positive grade 10 triangle, figure out little alpha, and then either add or subtract it from 180 or 360 to figure out theta. And then our last one, given one of the 6 trig ratios, so that was like the question we just did where we were given the cosecant rather than just a point on the terminal arm. We can sketch and label our angle in standard position, determine the other trig ratios, and determine the measure of the angle if we're asked to.